Hi everyone, and welcome to the first lecture in our online class for CIS 577. This is the graduate level computer networks class. So before we get started, just a couple of things. So the assumption is you've had either CIS 475 or some sort of functional equivalent. So the things we're going to cover in the first 3 weeks are basically a review to kind of get everybody on the same page, and then we're going to get into more details. So the things we're going to cover the first 3 weeks, we're going to go through relatively quickly because it's basically an assumption that you know this information, and this allows us to have everybody that's had, perhaps networking courses from different universities to kind of all get on the same page. So, like I said, we're going to cover the basics. Now, the approach that's in the book that we're using computer networking, a top-down approach. The reason I really like this book is that it does the opposite of what most computer network classes do. They start from the physical layer and work up. And it has been shown that the best way to teach networking is to start from the application layer, which most folks are familiar with on a day-to-day basis, and kind of work their way down to the physical layer. So just kind of talk a little bit about layering. I think all of you know that the whole concept of layering is that it's basically an artificiality, kind of an academic exercise. So many years ago, back in the 70s, when basically every networking vendor, and there weren't a lot of them, but every networking vendor had their own proprietary way of doing business. And so there was an attempt to provide a standard that all the industry vendors would use, and that became the OSI model. We're going to touch upon that a little bit in this class. But the OSI model was basically developed as kind of an open system standard. And of course, the problem with the OSI model, it was far too complicated and far too expensive to implement. I've actually, back in the 90s, actually used networking cards that actually used the OSI model. They were significantly more expensive than your basically IP networking cards for different reasons. Part of it was development cost. So what happened is basically TCP/IP kind of took off and basically became what's called the de facto standard. So the old IP networking layers are kind of modeled after the OSI model, but it was really an attempt to provide that same sort of logical functional differentiation, as it were. The reality is the layers are not as concrete as we'd like to believe sometimes, but from an academic point of view, and it's kind of how they're described in the industry, we're going to use that layering concept in the course. So we're going to start off at the top of the application layer, and we're going to let's move on through the slides. Like I said, there's a lot of material here. We are going to go through this relatively quickly because this is a review. And the 2 weeks after this, we are going to cover a lot of material, and we're trying to get everybody on the same page. So let's get started. So what type of things we want to cover in this learning module? So we're going to talk about some of the application architecture. So we're going to talk a little bit about differences between client-server and peer-to-peer. Then we're going to talk about some specific applications. We're going to talk like HTTP, file transfer protocol. We're going to look at the different email protocols, domain name server. We're going to look at how peer-to-peer applications work. Not on here, but we're also going to talk about network time protocol and we're going to look at some of the basics of socket programming. So like I said, we're going to start off with a conceptual discussion, and I'm going to talk about client-server versus peer-to-peer, and then we're going to get into talking about some specific protocols. And those are the ones that we're going to focus on: HTTP, FTP, the email protocols, domain name services, and network time protocol. And we're going to look at some example code to how to set up a socket API. So here's some network applications, different types. We're not going to cover all of them. We have a discussion forum question. So what I'd like you guys to do is, after this lecture, is kind of look at some of the networking applications that we didn't cover, and in a sentence or two describe how they work. Kind of similar to what we're going to describe today for the applications we're going to cover in detail. But you can see there's a lot of different things besides what we talked about: email, web page browsing. There's also text messaging, remote login, multi-user network games, streaming video, voice over IP, which is actually can vary in how that's implemented, real-time video conferencing, time synchronization, we're going to talk about, remote node statusing, monitoring, controlling, which we're going to talk about when we get to network management, and distributed applications such as distributed database applications would be a good example of that. So take a look at this, and you may use this when you do your discussion forum questions. Give you some ideas. There's probably others on this list that maybe I'm not aware of. Maybe you have used. Maybe something that's new and up and coming application protocol. Feel free to share that in the discussion forum. I think one thing we want to do in this class is to educate each other, because things in the networking world happen very quickly. We're not doing this in this class, but in the undergraduate class I actually had the students go off and do a research project, and a lot of them came up with some new things that are out there that I wasn't aware of, because it wasn't something that I was currently using. And every day there's something new. So if you have the ability to share something new in this class, especially in the discussion forums or how you answer questions, that's a real plus, and we can help everybody get something more out of this class. So let's talk a little bit about what happens when you create a network app. So let's say you're a developer, you're developing an application that's going to run on a desktop, going to run over the network. So basically, the application layer is really kind of like an API. So like anytime you write a program where you're going to use some sort of standard methodology to pass data on somewhere else, whether it's inter-process communication or shared memory or a networking application, there's some sort of standard that you're going to use. So in creating a network app, you have to write a program that's going to use those standards, so the program can run on different end systems, and you're going to communicate somehow with one of the other network layers. So you have to foster communication over the network. And for example, a web server software communicates with browser software. So in that case, you have to have an application that's going to run both on a client and a server. It's going to run with different browser software types. Using some standards, whether you're using Microsoft Edge or Google Chrome, it's going to run on all of those different browser applications. And you're running something that is going to run on different platforms, whether it's Windows or Mac operating system, or a PC or tablet. It doesn't matter. So there's the assumption that there's going to be some portability. There's no need to write software for network core devices. That's going to be transparent to the application developer. So there has to be some standards in place so the data can get passed on through the network. and that's where the layering comes in. So at the application layer, you're basically passing on data through an API through the next lower layers. So basically, it looks from a functional point of view that each application is speaking to another application without any awareness of what's happening below the application layer. So there are basically two main structures, two main architectures in a network. Usually things are set up in either the client server or peer-to-peer configuration. So I'm going to talk a little bit about the differences. So in a client server architecture, which I assume pretty much everyone is familiar, we have a server that is always on, always available, whether it's one physical server or multiple servers, we're going to get into later on, especially when we talk about enterprise computing. There's some sort of permanent IP address, or probably more likely a permanent host name that a client knows how to get to that server. You have to have some sort of awareness of where the client needs to be aware of where the server is. Usually they're in some sort of data center for scaling, and the level of difficulty for scaling basically depends on the application used. It's obviously easier to scale a simple web server where you're just pulling down web pages versus a database server where the user can go and change data, and you have to have some sort of data consistency. So we'll talk about those types of differences, but this is basically your basic concept of a server. Always on and always available and easy for the client to find with some predefined IP address or host name. And the assumption is, and one of the issues are, when you have one server or one set of servers, scaling is a problem because your clients can grow faster than your server capability. It's not a linear growth pattern. So that's a potential problem with client servers. On the client end, it communicates directly with the server. There's no requirement for the client to be on all the time, so it can be on intermittently. You can have a dynamic IP address. There are mechanisms to foster that communication that we'll get into later on. And unlike in a peer-to-peer, clients do not communicate directly with each other. What's become more popular in recent years is the concept of peer-to-peer architecture. They don't require an always-on server. Basically, the way that peer-to-peers work, each peer is doing the job of a client and a server, and they're kind of sharing that load. So basically, unlike a client-server architecture, the peer-to-peer hosts communicate directly. Peers can request service from other peers and provide service to other peers. So basically, the way this works, peers are not just pulling data from the network, but when they pull data, they're basically saving a copy on their machine that allows that data to be pushed to other clients. So they're doing both the role of the client and the server. Because of that, peer-to-peer architecture is basically self-scalable. So every time you add another peer, you're adding not only another client, but also another data server as well. So adding peers actually adds to the capacity of the network, since the peer is both pulling and pushing data. One of the disadvantages is, unlike a client-server system where the servers can be a secure facility and you can have all of your cybersecurity software running on that server to control the data. There's no central control in a peer-to-peer architecture, so it is by definition insecure. And if I wanted to exploit a network, it would be a lot easier for me to exploit a peer-to-peer network versus a client-server network. Not that that can't be done, as we'll get into when we talk about cybersecurity, but it's definitely more insecure than a client-server network. Peers are intimately connected and change IP addresses, so it's very important because of that you don't have a peer that has the only copy of a piece of data that you need, because if they're not online, you're not going to get that data, and that does become a problem in certain situations. And there's some examples of peer-to-peer applications like file sharing, like BitTorrent, and also Skype uses the peer-to-peer paradigm for making telephone or voice and video telephone connection. So let's talk a little bit about process communication. So, of course, I'm sure everyone in this class is familiar with processes. We learned about that in our operating system class. So that's a program running within a host. And obviously, operating systems allow for different types of inter-process communication, whether it's using a fork or an exec or shared memory. And also one of the ways for inter-process communication allowed by an operating system are allowing an application or process to communicate over the network, connected to some IP address and some port. And processes in different hosts communicate by exchanging messages, so the API would have to have an ability for the process to push and pull data over that API and exchange messages, and how that gets handled is taken care of by the lower layers. So looking at processes from the client server versus the peer-to-peer point of view, in a client server, your APIs are going to be set up so that the client initiates communication and the server waits to be contacted. In peer-to-peer architecture, each host on a peer-to-peer architecture have a dual role, so they're actually acting as a client process and a server process. Okay, next up, let's talk a little bit about sockets. So like we said, when there's inter-process communication, you have to have some sort of API, some application programming interface, and the socket is the one used in the networking paradigm. So basically the socket is basically kind of like the door between the application layer and the transport layer. So basically the sending process shoves a message out the door, so that's basically the client sets up some socket and it sends data out that socket, and then it's up to the other network layers, which are controlled by the operating system and eventually by the driver on the networking card. Sends that data through, sends it out on the wire, and then there's some other socket at the other end that's going to receive the message and send it to the application at the other end. So why don't we stop right here for now?